Dear students, in last class we have already studied about the bioassay. We found out the bioassay advantages, disadvantages. Now this time we are going to find out uh, types of bioassay. Types of bioassay. I told you bioassay means it is a assay where we are going to insert the biological objects. Okay. So, in this bioassay, whenever we are going to discuss, remember that there are lots of advantages and disadvantages are there. That already we have discussed. Okay, in the previous video, you might have seen previous classes I told you. Okay, so the advantages where we are finding lots of advantages, along with that some of the disadvantages are there which we cannot omit exactly. That is called as majority. The disadvantage is error, the genus error is there, the species error is there, or whatever different type of skilled variation. Okay, so lots of variations are there. So by finding all these things prior to start the bioassay, you should know these all the disadvantages are there. You have to try to overcome, means you have to try to overcome by omitting that points which may alter your assay method or which may alter your standard protocol. So when there is a application or there is a modification, it is possible in bioassay. We must find out the types of bioassay, means which methods is going to give us the best result we are going to get. Okay, number one, types of bioassay. If you are going to broadly think that bioassay is majorly divided into two types. Okay, one that is called as gradient method, and number two that is called as quantile method of bioassay. So number one, it is called as gradient method. Number two, it is called as, what is this? Quantile method of bioassay. Please remember these two terms very minutely, because this is the basics of bioassay typing whenever you are going for classification. This two is the major classification. Gradient, it is means, what is the meaning of gradient? Here the response, it will come in graded manner. The name itself, it is telling gradient. Gradient means it will come in the graded manner. What is the quantile method of bioassay? Quantile method of bioassay means here not like gradient, it is the quantile, means here you have to tell yes or no, that's all. There is no different opinions on this quantile method. We should say in a single term, that is a all or none phenomena method. Means either you will get the result or you will not get the result. Both I will try to clarify with you. Remember that the quantile method of bioassay, whenever we are going to find out this, suppose you are taking a tissue, on that tissue you are going to give a drug. Example, very best example, I will take acetylcholine you are giving on the smooth muscle. Acetylcholine produces contraction on the smooth muscle, that is known to you. Okay, so if you are going to think that acetylcholine, if you have taken the tissue, you have mounted the tissue in your, what is this apparatus, kymograph apparatus. On this kymograph you are giving acetylcholine in dose dependent manner. Dose dependent manner means first you are giving 0.1 ml, next 0.2 ml, next 0.4 ml. So this geometrical propagation you are doing, that you are increasing. Gradient method means in dose dependent manner you are going to give, and the response it will increase. As the dose will increase, the response length will also increase. This is the gradient method. Quantile method means all or none phenomena. Here, suppose any drug which is having anti-diabetic activity, this particular drug you are going to give, and insulin, if you will give, automatically it will reduce the, what is this, sugar level, or it will means invert the hyperglycemic situation. So if you are going to give that insulin, it will reduce the glycemia. If you are giving something else which don't have anti-diabetic activity, it will not reduce the glucose level. Okay, so in this situation, if you are going to give a drug in a diabetic subject, it will, if it will reduce the sugar level, then it is all. If it is not reducing the sugar level, this is none. Means here yes or no phenomena. Means actually whether it will produce the action or it will won't produce the action. This is called as quantile method of bioassay. These two are the most important or broad classification of bioassay. We know bioassay, when we are performing, previous class also I have told, bioassay may be classified on another one method, that is called as by depending on the, what is this, intact animal, or by depending on the dissected tissue. Means one is intact animal, another one is dissected preparation. So number one, if we are going to find out that intact animal, one of the example I can give you, analgesic activity of any drug. You are going to find out whether it is having analgesic activity or not. You are doing this bioassay. Here, dissection of that animal or sacrifice or any type of surgery, it's not necessary. You just only inject or just only insert the drug to the animal and find out whether it is having analgesic activity or anti-inflammatory activity or anti-emetic activity. All these activity, dissection is not necessary. Okay, so this is the intact animal. Most of the cases the animal will be survive. After the experiment, the animal will be survive. Only you have to keep that animal for a tenure of time for that washout period. So this is called as intact preparation. Number two types you can go for, that is for this. In this case, you are going to take the animal, you will sacrifice the animal, you will take a particular tissue preparation, and that tissue preparation will be useful for the your bioassay. So here you are going to sacrifice the animal. Suppose you are taking the rat colon, and this rat colon will be useful for the bioassay of acetylcholine. Okay, you are going to find out the activity of acetylcholine by using rat colon. By keeping inside of the rat colon, it is not possible. Or you are going to find out the cardiotonic activity of digitalis. You have to isolate the heart. Okay, and this heart you have to mount in the apparatus, then you are going to find out. So here you are going to sacrifice the animal, or you are doing some surgery on that animal to get some of the tissue preparation. So these two are another types of classification. But when we are going to find out the major and the most important classification, we are going to find out some methods of bioassay. Exactly the methods of bioassay, if you are writing that, so we have to find out this. Now we will discuss on that methods. Number one, that is called as matching point bioassay. Matching point bioassay. Here here this is one of the oldest method of bioassay technique. I taught you in the previous class what is standard. Standard means which the substance, its activity or its purity, it is known to you. Okay, that is standard. which is already established. So here matching point bioassay means all the times bioassay what for you are doing, for quantitative or qualitative whatever it may be, but to identify the unknown or to identify the quality of the unknown. Okay, but if you are going to find out the unknown quality, you have to compare with the standard which is known. So here in matching point bioassay you have to take one standard DRC, you have to take. Along with that you have to take one, what is this, test DRC. Okay, so this standard DRC and this is the test DRC. So the name itself telling matching. You have to match this response, any of this response with this response. Okay, so exactly it is very hard to perform without error. So matching point bioassay is, we can say here the error is more or the precision is not good. That's why nowadays we are avoiding this technique. Matching point bioasay means one DRC of standard, one DRC of test. Compare their responses. Okay, which response can overlap to the standard one. So this is the matching. So exactly precision is poor. That's why we are avoiding. Next, the next method we are going to find out, that is called as bracketing bioassay. This is bracketing bioassay. Bracketing means, you know the meaning of bracketing means, this is bracket. It may be first bracket, second bracket, third bracket, whatever it may be, this is bracket. So bracketing bioassay means you have to make a bracket of standard which will bracket the dose of test. Okay, so bracketing bioassay, that is also a ancient method, and here also precision is poor. That's why we are still avoiding this technique. So the next method we are going to find out, that is called as interpolation method of bioassay. So the third we are going to find out, that is called as interpolation method of bioassay. In this interpolation method of bioassay, you have to take the standard DRC, then you have to take one unknown response. Just you have to remember that response lies in between of the smallest and greatest response of standard. This unknown response, this is the standard DRC. So this unknown response length, this length, it should lies in between of this smallest and the longest response of standard. If the first response you got smallest, then you increase the dose of your unknown, so that you have to get a response which length lies in between these two. Now you have to select, you have to measure the length of these responses in millimeter. Dose is already known to you. You know how much concentration of acetylcholine or standard what you have given. Suppose here you have given 0.1 microgram. Here 0.2 microgram was present in your solution. 0.4 microgram was present in your solution. Like that. Now you have to do what? You have to make a graph. In this graph sheet, here in the x-axis, you have to take the concentration. In the y-axis, you have to take the response length. So, in 0.1 microgram, you got some response. In 0.2, once again you got some response. 0.4, you got some response. 0.8, you got some response. 1.6, you got some response. You put that response, okay, and here you are going to take the log of dose what you have taken. So this log dose versus your response in millimeter, if you will plot this, you will get a sigmoid curve, a shape. That's why it is called a sigmoid curve. On that sigmoid curve, the response length of your unknown is known to you. So suppose the response length of your unknown lies here. So you intersect this response and you come down, you will get the concentration. So suppose the unknown response length, what you got in a particular sample or particular dose. Suppose it was 0.1 ml. So in that 0.1 ml you got this response. In this 0.1 ml of unknown, here suppose this is the response 0.1 mg, this is 0.2 mg, it is 0.4, so suppose this is 0.3, near about. So in this 0.1 ml of your unknown, 0.3 mg of drug of your standard is present. So by this way, this is very means what is this in broad I told you. So this is the calculation, type of calculation. So from the standard DRC you have to plot a graph. It will come to the sigmoid curve. On that sigmoid curve, if you will intersect the response length of your test, you are going to get the concentration. This is our interpolation method of bioassay. The next we are going to find out, that is most important, and nowadays we follow this method very much, that is called as multiple point bioassay. Multiple point bioassay. The name itself, it is telling multiple points are there. What is this? I can give you the types of multiple point bioassay. I can give you the example 3-point bioassay. I can give you 4-point bioassay. I can give you 6-point bioassay, 8-point bioassay, or so on. You can keep on increasing the number, okay, up to a certain limit. So 3-point bioassay, 4-point bioassay, 6-point bioassay, these different types of bioassays are there. For that, I'll take the very best example, that is 3-point bioassay, because as per your syllabus, this is also there. Okay, so you have to know. Then 4-point bioassay easily you can understand. 4 and 6-point also I will tell you. So remember that here also you have to take a standard DRC. Next, you have to take a test DRC. Now, what I told, in 3-point bioassay, 3 of the point has to be selected. What are these 3 points? These 3 points are named as S1, S2 and T. So S1 is the standard one, S2 is the standard 2 and T is the test. So we have to select S1 and S2. Remember that don't select any of the days. This is the standard DRC. Don't select any dose which is 100%. Okay? Try to select the sub-maximal doses, means from here to here you can select the dose. So suppose S1 you are selecting this and S2 you are selecting this. So these two doses you are selecting, because S means standard. These two doses you have to calculate or you have to find out from the standard DRC. You find out to T. T you have to select which dose lies between the response length between S1 and S2. So the response length, it should be larger. It should be larger than S1 and it should be smaller than S2. So we can select this one as T. So here some response is there. Suppose this is 0.1, 0.2, 0.4, 0.8, 1.6. Here also 0.1, 0.2, 0.4, 0.8, 1.6. So we got the point S1 is 0.2 ml of standard, S2 is 0.8 ml of standard, and T is 0.8 ml of test. This is known to you. From the graph you have got this. Now you have to do the Latin square design. You have to know the Latin square design. What is this Latin square design? I told you 3 points are there, S1, S2 and T. So you write this in different manner in the next phase. S2 will come first, then T, then S1, then once again T, then S1 and then S2. So like this fashion you have to write. Okay? S1, S2, so the first we got S1, S2, T, second we got S2, T, S1, third we got T, S1, S2. If once again you will write this, it will come back to S1, S2, T, same as this. So not required. So if you are making this direction, total 9 graphs you can get. So 3-point bioassay means 9 graphs you can get. Now you have to give the dose of S1 in this graph sheet. So you will get a graph of S1. Now you give the dose of S2. Now you give the dose of T. Once again S2, then T, then S1. Then lastly it will be T and S1 and S2. So 2 DRC along with 9 graphs. This is the 3 points bioassay. So minimum multiple point bioassay it is possible, that is 3-point bioassay. So this, what is the purpose of doing this? Because as the tissue will be harvested or tissue will be cultivated, you are cultivating because a number of doses you are giving, number of times drugs you are giving. So continuously you are giving the drug, tissue is losing its sensitivity by some extent. So when this series of response you will take, automatically that error will be divided in all the responses. So average of S1 means 3 numbers of response you have to measure and you have to take the S1 average, like that S2 and like that T. So all the cases the error will be divided and ultimately we are going to find out it is going to give you a better precision or minimum error. So this is the 3-point bioassay, one of the best method we are following. If you are going to find out the far more purest method, then we have to increase the points. What is this points? Nothing else. Same like that DRC of standard, DRC of test you have to take. You have to select here now 4 doses. That is the 4-point bioassay. What is this? S1, S2, T1, T2. Remember that here 2 formulas are there. What is this? S2 by S1 should be proportionate with T2 by T1. This reasoning you have to keep in your brain prior to selecting the dose, prior to select the response. You should find out ST by S1, S2 by S1 always should be proportionate with T2 by T1. So when you are going to find these 4 responses, you have to select 2 S1, S2 from the standard and T1, T2 from the test. So remember that always S1, S2 will cover T1 and T2. So T1, T2 will be never larger or smaller than the S1 and S2. So standard always it will bracket or it will cover the test responses. So when you are going to find out this phenomena, you are going to get Latin square design S1, S2, T1, T2, then S2, then T1, T2, S1, T1, T2, S1, S2, T2, S1, S2, T1. So T2, S1, S2, T1. Next it will come S1, S2, T1, T2. So that's not required. So 4 phases of graphs we got. So 4 4s are 16. So 4 point means in Latin square design, after 2 DRC you have to plot 16 curves. Then you have to take the average of all these things. So this is a 4-point bioassay. See, so here the precision will be better than 3-point bioassay because you are increasing the points. As the points will get increased, the precision will be more. Okay, give you some idea about 6-point bioassay also. So I think now it is very clear to you. You are very comfortable now. 6 points means you have to find out the total 6 points will be there. S1, S2, S3, T1, T2, T3. So total 6 points. Here 6 points means Latin square design it will be S2, S3, T1, T2, T3, S1. Next S3, T1, T2, T3, S1, S2. Next T1, T2, T3, S1, S2, S3. Next T2, T3, S1, S2, S3, T1. Next T3, S1, S2, S3, T1, T2. Next if you will go, it will come to S1, S2, S3, T1, T2, T3. Same as that. So here 6 are 36 graphs. Total 36 graphs you are going to get. So in that 36 graph you have to plot after the standard DRC and the test DRC. So these 36 graphs, when you will plot, each concentration means each responses, you are going to get 6 graphs. So all the averages, it will be 6 graphs average. So it is a very lengthy procedure, very time taking procedure, but once again you are increasing the points means definitely it is the purest form of bioassay. Okay, we should say whatever I taught out of them. Okay, so here the error will be very minimum. So whenever there is a type of bioassay, so we have discussed all that types of bioassay. Please go through in detail, and next day onwards we are going to start the bioassay, different bioassay directly. Okay, so take care till today, be safe, we will meet in the next class.